Hello and welcome to my video where I talk about radicals. And I'm going to show you a little bit about how to simplify radicals and also how to switch them from mixed radicals to entire radicals. So first of all, let's get started with some definitions here, so we're all talking on the same page. We have, first of all, definitions about what is a radical, what is a index, and what is a radicand. So a radical is described as the entire square root, or cube root, or fourth root in this case. So a radical is whenever we use the root symbol, it is a radical. And the entire thing here is called a radical. Okay? The 4 in this number is the index. So that is the little 4 up here, is the index. And if it's a square root, there's an invisible 2. Okay? And if it's a cube root, what's the index? 3. Okay? So that's the index. The radicand is a thing that's being rooted. And yeah, that's what we need to know for now. We also have a little bit more down here. We have the term mixed radical and the term entire radical. So it's actually really easy. It's kind of like when we did fractions in like junior high. Mixed fractions have a number in front and the fraction itself. Improper fractions were all in one, and we start using improper fractions for everything after a little while. Same thing here with radicals. So we have mixed radicals, which is right here, and we have entire radicals, which is right here, where the entire number is inside the radical. That's what makes it an entire radical. Everything, the entire number, is inside the radical. Alrighty, let's go ahead and try some example questions. Okay, so let's simplify the following radicals, and are we going to get bad answers? No, okay, it's going to be fine. We're going to have good answers. Okay, so let's simplify the following radicals. The trick to doing that is to first do a prime factor tree. So what are the prime numbers that multiply to get the original number? So in this case, it's nice and simple. 3 times 3 is 9. So what we're going to do is we're going to write it like this. And actually, now I'm looking at this question. This is a silly question because nothing can be changed. It's already in simplest form. Okay? That's okay because our next question is a good one. I already did it in my head here. So we are going to split this up into its prime numbers. So what number can we divide evenly by 27? Hopefully you can think of 3, which if we divide it by 27, or take 27 divided by 3, we'd get 9. Then if we did that again, 3 times 3. So now what we can do is we can write this as square root of 3 times 3 times 3, based off of our prime factors here. Now what we can do is, because it's a square root, which is an invisible number 2 there, we are going to take 2 of our numbers, and we're going to put that outside, and we're going to keep the leftover number inside. So just so that we're all clear, this number ended up here, and this number ended up here. All right. Let's try another 2 examples here. So we have the square root of 8, which is 2 times 4, and then 4 is 2 times 2. Okay. If your calculator is giving you this answer directly, it is banned on our test, so just a heads up there, but you have to be able to do this by hand. So anyways, what we're going to do is go 2 times 2 times 2, And because there is an invisible number 2 here, it's a square root, right? We're going to select a group of 2 of them, and then we are going to put those on the outside. And we'll leave what's left over on the inside. So that's our final answer. Okay, we're going to do another example here with the number 32, and actually I'm thinking we want to make this a bigger number, so I'm just going to edit that quickly, and instead of 32 I'm thinking like 256, a really big number, so that we can spend a little bit more time on the prime factor tree. All right, so let's try this with the prime factor tree now. So we've got 256, and we need to come up with a number that can divide it evenly. You may or may not be able to come up with a number right away, but if it's an even number, you can certainly still divide by 2. So let's just do that first and see if anything else comes into our head. So 2, if you divide by 2, you get 128. Now, again, you might not be able to get something in your head right away. Maybe something does pop up, but if not, divide it by 2 again. It's an even number. The 8 is an even number, so therefore we can divide by 2, and we get 64. Now that it's 64, hopefully it's a little bit more clear that we can divide by some other numbers here, other than 2. We can do 2 and 4. And we can do 2 and 4. And now, look at how many 2's we have. That is a lot of 2's. So now what we can do is we can put all of those 2's. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's annoying. It's going to be well, probably no one's tried this question. If you were to do the question as is, it will be groups of 4, and then it will just simplify to a number. That's boring. You know what we should do? We should do a group of 3's. Is that going to work out better? Yeah, it will. This one, the reason why I'm saying this is simply because it's going to give us more of a broader understanding of this type of question. So anyways, let's say it's cubed. So, whoops, which would say this 3 tells us we want to take out groups of 3. So here's one group of 3, here's another group of 3, and there's 2 left over inside. So what you do is you take the groups of 3 and you put them outside. So this one became here, this one became here, and then you take the leftover part and you put them inside. So there are 2 of those inside, so I just move them over here. Okay, finally, as our last step, we can multiply all that together. So 2 times 2 on the outside is 4, and whoops, it should be cube root, and 2 times 2 on the inside is also 4. And I just forgot to include my cube roots on the blue radicals there. All right. There it is. Okay, hopefully that helped you understand simplifying, which is the more important process. Now for the less important but also important, this will be on the test as well. So this is going in reverse. Same type of question, but now in reverse. So change the following mixed radicals into entire radicals. So what you do is you basically have to imagine that it has that invisible number 2 there. And that's going to tell you how many of the front number are going to exist on the inside. Okay? You probably can't do that in your head, so what you're going to do is just try it out in your calculator, not the square root part, but the 7 times 8 times 8 part, and we get 448. So this is root 448. Okay, so we've changed it from a mixed radical now to an entire radical. Okay, I highly recommend pausing the video here, trying some questions out, and then pressing play to see if you get the same answer as me. But let's continue on at this point. Okay, so same sort of thing again, but now this time there are 3 of them. So it's 2 times 2 times 2, and then times 5. So 10 times 4, so it's 40. And this is a cube root, so cube root of 40. Okay, the next one, there's a 4th root, so it is 3 times 3 times 3 times 3 times 4. So 12 times 9 times 3 again. No, I'm going to do that in the calculator as well. So 3 times 3 times 3 times 3 times 4, 324. Okay, and then our last one here, again, this is an invisible number 2, so that means it happens twice. So 3 times 5 times 5. And notice there's no specific order that we have to go in here. I'm just choosing to do it in like smallest number to biggest number, but it actually doesn't make a difference. So 25 times 3, so 75, so square root of 75. There you go. I hope this video helped you understand the basics of what a radical is, how to simplify a radical, and how to basically reverse it. So how to make it mixed to an entire radical. Hope this video helped, and good luck.